Where is my mouse? I think now it's strange. Lasers! So until the talk, I can just like here.
How are we deploying? Oh, we are live.
Yes, smile the camera.
Ciao.
You're famous now. No, it's fine. This is the part where they say on talkk that we will cut this part out. And then they stream in time and then we go. Presentis ka, et võtab sõjalt teised. Võta ainult sealtpoolt.
It should be.
If that will make you happy, yes.
That makes it feel better. Free online.
Voice is clear. Nothing on the stream. I think it's running because it should be live. Yes. And we didn't do the mic either. So you can hear something's going on. I didn't see. It's interesting to think about how much gold it actually took for the good stuff. It wasn't a lot, but how much time?
For this demo?
No, I mean the deployment system itself. We haven't written like that amount of massive stuff. It's just connecting all the cables. That's what took us time.
We make it harder. This is groovy. Because when I wrote the one for the runner, I wrote it like with Java, much easier. And just
Yes, the idea is that we don't understand it. That's actually supposed to be like this hardware. We're going to die soon. This one is about the same.
Start gathering around. A few minutes till showtime.
1 minute.
I have 1 minute?
It's running.
I have two. I have at least 2 minutes.
You're famous now also on the video stream in the internet.
Please.
Yes, I'm on the internet now.
Respect the
But I don't have any notes.
We should have taken down the videos. This is like hazard.
I think we're under provision with the chairs a bit.
Uh-huh.
Well, it happens. What are you going to do? Yes, huge. Should be fine. Should be super. Awesome, great. Does it seem like it, or do we have like a lot of people today? Is it more than we had previously? Maybe. So okay, it's almost time. Maybe I can already start. So, welcome everybody to Cloudageddon. Cloudageddon number 3, as the name implies, it's our 3rd event. Have a couple of really great talks today. Thank you everybody for coming. Hope you have a good time enjoying the talks, the company, the snacks and the drinks. The schedule is on the board, so right off the bat in a few minutes, Mustafa and Martin from Fortumo will talk about auto deployment a little bit. Then we'll have a small break, about 30 minutes, where you can network, eat some more if there's any left, drink, and then come back here. And then Alar from Concise Systems will talk about whether or not you should opt into AWS and how scary that is. So should be a fun ride. And then after that, once it's concluded, we'll have, the doors will be open until about 10:30. You can hang around, chat, have a few more drinks, and then sooner or later we'll start kicking you out if you don't leave voluntarily. So, once again, thank you everybody for coming, and now I will give word over to Mustafa and Martin for the auto deployment talk. So, big hand.
Hi, I am Mustafa, software engineer at Fortimo, and here's Rose, tech lead at Fortimo. And today we will talk about how actually we deploy our applications daily at Fortimo, and why did we started to think about how actually we used to do the deployment and now the new framework that we have developed. But first of all, I think that if you have any question, you can use this app, because this will be our demo app that will demonstrate how we actually use the auto deployment for deploying our application. So you can also submit your questions here during the presentation if you want to ask any question. So, okay. Do you want still?
No, that's okay.
I didn't get it.
Okay, you can go. So, how actually we used to deploy that Fortimo before? First, we used Capistrano, Ruby scripts that enabled the developers to deploy their code from the machine. So previously, the developer has to build their the application or the changes locally and start to deploy and actually access the machines and configure everything. So that was a problem for us, because now configuring the secrets and all the variables for the applications manually, this is not a good idea for especially when something happened wrong, when something wrong happens, so you start to think about, yeah, I have to go manually and start edit or even remove some configurations and add some other. So that was one of the motives why actually we started to do that. So also the capacity of during the deployment, because here in Fortimo is the finance, the applications we have and the services we provide, it's really vital and critical, like especially when you start to deploy to production. So if you think about it, when you just start to deploy, if you have n number of machines and they start to deploy to one of these instances, then we lose the capacity, or the traffic now is somehow at risk, because you don't know actually if really what you deployed will fly or not. So that was one of the reasons that we wanted to find a way to solve this problem for our deployment. So we decided to automate everything. That's a good idea, because the manual work is not really safe in the sense of human errors and the panic you will have, especially if you deployed something that you see, yes, my instance now is gone, or my applications really start trashing data. And for us, data is really money, because it's literally money, payments we do. So we started to map out what we really want to do, what we really want to have. First thing is repeatable deploys. So we want to make sure that what I deployed before, or what I'm going to deploy, I can reach the same state again easily, without need of magic scripts or going there or start to open the README and see how actually I can go to this version or do that, or how I can configure this instance. In the sense that that's really hard for developers, especially here we deploy applications almost like hourly.
All the time.
Yeah. I don't think that anyone, especially with the microservices, you should be doing this like daily, or at least once daily. So we wanted to make that really easy. Also, one thing is to have versioned secrets and configurations. Why? Because imagine now, if we have a new application which uses different type of configuration, or
different secret. So now what happens if I go there and I start, okay, I put this change to configuration in the machine manually, and or by any other means, still you change it, the configuration there, and start application, and suddenly you found that it's broken. So what you do, okay, let's roll back. First thing, okay, open readme, because of course you forgot how to roll back. So see, yes, I should do that, and fight for a while with Ruby. For this, that was the case for us, and then start to roll back to the previous version, but still broken, and you have no clue why, because your configuration or your previous configuration are gone now. So you still have to find out how actually the previous configuration, or how do you just to get the previous one, or which one. So having this as a version 1 was one of the important requirements for us. And one important thing also here was we want less or SSH less servers, which means it's not a good idea to go yourself or any developer to go there to access and try to fix stuff manually, or to put the secrets. Or so now most of our applications developers don't access the servers. They don't have like direct connection to this instance, and it's not easy to go and get anything from this. So yeah, that's what one of the goals, and also immutable deployments. That's again the same thing, that you should not, whatever you deploy now, you should not be changing it. If it's really bad, just get rid of it, go back to the previous one. Don't the set of machines or the set of changes you have done, and this should not go and manually be changed. Most importantly, as for our users, Windows users, because it was, I remember I use Windows, and I remember the last one was Tunnel here, the newest one in member, the team. It took him like long time to fight with Ruby and Windows and try to start to deploy Capistrano ones. It wasn't really easy. So yes, so we decided to think about something really easy. As you can see here, it's really descriptive, and anyone can understand what are we doing. So the process actually, generally it's really easy and logically you can see. Now we have our application. This is the state, the first state for the application. So we have 2 instances, or maybe more, or only one. And this is the load balancer that actually forward the traffic to the instances. So once you have new set of change, you need to deploy new instances. So here, the green ones are the new ones. So now we have the application runs on 2 different versions here. This is the new one, and this is the old one. And once it has been verified that and validated that it's actually really good and no problems with these instances, you can just get rid of these instances and keep the newest one. So this way we didn't lose the capacity of our traffic processing during the deploy, because now actually we increased it during the deploy. We have more or double of the instances during the deploy, and then we were able to deploy it easily. So as I said, so now how we do that actually more in more detail. For every change you do, or every set of changes you do, it's versioned. We have our build server version every build. Every push you commit or push to the repository, it's built and ready to be deployed. And so you can, every version of the application, you can just deploy it to a new set of machines, and if something wrong happened, we also mark it down. So this set of change was really bad. So in that sense, no one can actually go to this change or this state of the application and try to deploy it again. So that will not happen. So as you can see here, how actually the tag our application. So every app that has a build, and we also mark what we deployed. So we deployed this set of changes or this version, so we mark it as deployed. So because if we roll back from this this version, so it will be marked as bad. This how actually it looks in also more details, or how the components we use to make the deployment happen easily. So the developers should push their commit into the source control you have or whatever you use, and then the build server will start to automatically build every set of changes you push, and we keep all the version or the build files into the SS3. So now we have an SS3 in the storage is the deployable versions of the application, and at the same time TeamCity like it doesn't have to be TeamCity, but this is our stack. So we have TeamCity as a build server starts to ask CloudFormation to prepare a new set of the application for this using this change, and then that will be the new instances that we have, and these new instances will get their configurations and the secrets from a different storage or different place. It's separated from the whole process, as you can see here. So we have here the immutable secrets. In some sense, we are almost where no one will know the password or the secrets. But now we have just here as versioned, and no one can change it. We just submit new secret, and it's stored here. And from your configuration, you choose which one. So that's help us to keep track which version was deployed with which secret and which configuration. So that make it easier. So what we used for the instance or the new versions, we used AVS actually provides these auto-scaling groups. Have anyone heard about this? Yes. So like the idea is to have to define a stack of instances that you want to be sure that you have this capacity of instance for this stack, for this application. So you decide that you want always like 3 instances, and every instance in different availability zone. So the auto-scaling groups enables you to do that. And also it helps us, or it makes it easier for the DevOps or whoever in the call, as now we don't want, if one instance is really bad and for natural causes from AVS or availability zone is down or whatever, now you don't have to wake up during the night and restart the application or deploy a new instance or whatever. So we can do it easily, and the auto-scaling groups will spin up a new machine once this group doesn't meet the capacity that you defined it. And it also enables you to define the load, depends on the period of time or you know your traffic, like you know your application and the expected traffic, so you can set also like some periods of time and how much instance to scale out and scale in, just to make it easier and also to manage the cost. that was how actually the applications, or the stack of our applications that we deployed. The load balancer also, AVS provides a higher level load balancer, which is application load balancer. In this sense, these load balancers actually forward the traffic in the application layer of the network. So we can define target groups, which in this sense, the applications that you are targeting, or different application on you have to forward the traffic into. So that helps also to to manage the new instances to join this target group, and when you remove like also the previous version, that's so the load balancer actually take care of that, so you don't have to change a lot when you have a new instance of machine or new stack with this one. This was supposed to be the previous one, because this is the when actually something really bad happens, or we just deployed the bad version and you already just got rid of the previous one, so we now are stuck with the bad ones, with the bad instances. It should be also easy for the developers to roll back to the previous version, so that also we provide with just one click, without any panic or to start read me or whatever, how I roll back or to ask someone. So the benefits of the framework that we have. Now Martin will start to talk about, and will present the demo, because we will have a demonstration how we change actually and easily deploy a new version of the application with just a couple of clicks.
Okay, so I can hold this. I don't plan to change the slides, but still. So the first benefit, like from our point of view, is like when we deploy a new version of something, we definitely don't want to drop the amount of traffic that we can handle. So if we increase the capacity just by the new nodes, even if they are bad, unless they cause like massive side effects, we are not going to suffer like in any way. Also we can quickly decide, okay, we actually need n+1 servers instead of like 3 or 5. In the old times when we had just regular boxes installed with Chef, then actually putting up a new box was a considerable amount of work. Now we can just slide it forth and back as we wish, way easier than the stuff that we had before. The platform independence you already mentioned here. Windows is not the only one that you can use, in the sense that of course we have people using Macs and Linux machines. Technically, since it's the build server itself that we use, TeamCity. Also, like it's just a web interface, so you can even use an Android phone or whatever you have, like any kind of trigger. It can also detect by itself the changes to the Git, so technically it could auto-deploy stuff into the staging and production. But in a payment company, you're probably never brave enough to do that, at least not in the production stuff, because at some point some heads would probably roll if you do something really awful. So we always have a hand on this one, and you like also, of course, you have to monitor the stuff that you deploy. For us, we have a bunch of automated alerting, and we also have a bunch of dashboards that monitor just visually to see, okay, the new machines show up, they start to handle traffic, they behave worse, better than the old ones, and we can differentiate on the dashboards how they are. And yeah, we decided not to do a lot of stuff by ourselves. That's why we have used AWS stack parts, but not abuse, make really lots of use of. The ALB is really good at handling all like the registration and deregistration of the nodes. Even if you start up a healthy cluster of machines and just one of them started on a bad instance, the ALB will figure out by itself, okay, this one is bad, will tell the autoscaling group, throw this one away, give me a new one, if the new one starts to behave, it's accepted into the cluster. Also, in the old days when we deployed, when the machine first came up, it immediately figured, oh, I'm ready for traffic. If you had an Nginx or something like this pointed at it, it tried to push traffic into that box. With the ALB, it always hits it at first into the status endpoint to check if this machine is actually doing fine. That's when it comes down to you as a developer to check, like, can you reach the database, the cache or whatever you have S3 resources. If you can't, you probably shouldn't start handling traffic anyway. If you just have a fixed box and you have told your Nginx that's where the stuff is, Nginx doesn't really have a choice. It will put traffic there and then we'll figure out, okay, maybe we'll drop the stuff from there. Just the everyday stuff with the continuous integration. Developers writing new code, not making mistakes when they upgrade, downgrade, rollback. What we previously, I think, didn't mention is that we have two phases where we can figure out that the new version is bad. One is when both of the stacks are active. So we see traffic on both of the stacks, and we can decide which one of them to drop in case of errors. Because it's not always the new stack that you should drop in case you start to see errors. But it's also after the moment that you have dropped the old stack, you actually figure out, okay, that was actually something that made the whole thing work. Despite you thinking that, okay, the new stack is good, if you didn't check early enough, that will cut you. So, yeah. And yeah, the environment-based config changes. Previously didn't mention it in very much detail, but in essence, in our repositories, we have template files for every environment that we plan to deploy to. And instead of the secrets, you have placeholders. So you can directly see from the repo, okay, production is running against this stuff, staging is running against this stuff. I cannot see the password. I don't really care about the password. I want to see that the database's address even is correct, that I have selected the correct amount of shards in some cache or something like this. If your config is only in the production server, you have to go there to check it. If it's in the repo and if it's versioned, you can even tell, okay, the version that was undeployed yesterday had that config. That's something that you didn't have in the past. And, once you mess up a config in production that accidentally makes things work and you deploy another box in the same way and it doesn't work, then you actually start to understand why this is even important. Because you don't understand why one machine works, the other one doesn't. And if it's all coming from the repo, always in the same shape, that never happens. So yeah, if you work around your config, I definitely suggest get it either into Git or some other kind of versioning system just to have a control over those. And there's a bunch of challenges. One said is monitoring. When you have new boxes coming up all the time, you will have a hard time at first keeping an eye on all of them. Amazon helps a little bit from their own side. For us, we have used a bunch of internal stuff, the usual Elk stack and Greylog, built-in stuff a little bit on the Unix machines, a bot that's actually watching around who is coming, who is going. But still, sometimes it leaves you in a let's say not desirable state, because some of the the monitoring systems, they assume that the set of machines is static. And thus, we are just popping up new machines the whole time and kicking the old ones away. And a bunch of the monitoring systems will just be screaming as hell, like, I have lost the server, I have lost the server, and I think it's right now it's pretty common that we lose a server like in the night against Sunday, and we see it in the morning from the phone because we didn't have to wake up for it, because a new one was quickly started and it's running. So that's actually a nice feeling. Sleeping is awesome. I really like sleeping. Then we are struggling a little bit with the database migrations. We are using jumper boxes probably like everybody else's, but we would like to integrate it more into the system. And databases are also a bit annoying in the sense that there are a bunch of migrations where you don't have a rollback possibility. So actually you should understand when you have locked yourself into a situation where you cannot pick the previous application version because it won't work. Why the rule of thumb is don't have like backward incompatible stuff. For us right now, since we operate 24/7, we don't have real maintenance windows in the sense we cannot tell all our partners like everybody stop now, we will maintain. Like, I don't know, Swedbank can probably do it. Like, say, morning against Monday, 4 hours, it doesn't work. For us, that window is not there. We cannot say 4 hours, nothing happens. Ran out of time. Well, then the status endpoints. When the machine comes up and is running, it has to tell adequately if it's healthy or not. That actually would require different checks to be done. Because if you for a moment don't see, let's say, a memcache error, maybe there is a DNS failure and you shouldn't start to rotate all your machines. Or if you actually have a DNS cluster failure and memcache disappears for everybody, you don't want to take down all your hundreds of machines and then bring them back. That would be a lot of noise on the network stuff. And and then you want to always check when you start up that you actually have the resource. Because if you start up your application, you cannot access the database, you probably are in a bad zone or don't have the correct settings, something. And yeah, the masterless design. In the old times, it was pretty common that somebody just by random picked a machine in the cluster, said, oh, you're the whatever triggering master, you will do all the triggering. For a while, this worked fine until this machine crashed and without recovery. And then you had like, okay, only the triggering config was there, now I have to put it up somewhere else. I hope I have the config somewhere ready for this. So that actually requires you to write code that doesn't need a master for whatever it's doing. Like simple stuff that we can pull out from our own pocket is like a subscription server, where you have subscriptions for some kind of services. They have to be triggered, but obviously you don't want to be triggered twice simultaneously. It shouldn't happen. We shouldn't fight for database locks on an array of instances, so they actually should chart out the work and figure out who is doing what, not sitting on each other's toes to have any kind of performance benefits. And that's actually the challenge, to write that sort of code. And then also all the backward compatibility stuff doesn't only have to be with the database, but also with the caches. If a new machine starts to cache in another way that the old machines don't understand, you will start to see errors on the old machines during the deploy, and that is not a very good place to be in either. So don't. And yeah, it's the last one. We want to have at some point that at least into staging, as soon as we commit to a machine, it will actually pull it up and do the automatic deploy without us touching anything. Right now, we still have to touch the build server just to say, okay, it's fine to deploy this into staging. Probably would like to get rid of this stuff, because in staging we are playing it safe. There is no real money involved, and it would save people time. Not so much time to save for the servers, but that's that. And yeah, before we get to the
We have the
demo.
questions already here.
Oh, we have questions.
Yes. And the first one was, why you know Docker? That was
Yes,
really
I
expected.
actually put that one there myself, so I felt it's probably coming anyway, so better if I asked it myself. When we started out to look around for the framework, Docker wasn't in the state that it's in now. There was a lot of hassles around random crashes, freezes and stuff like this. If you have to be a payment provider and you have to know what happens to every one of your payments, you don't want to be in a Docker frozen machine. That's not good. Is the most correct answer that they can have. You want to know what happens to every one of those payments. Like whenever you pay for something, you don't want to get the receipt for the machine. I don't know what happened. It's really hard to explain to anybody, to the merchants, to the telcos. So, yeah, and also when we initially tried out Docker, we gave it like a short try. We set up our own registry, tried to have secure access to it by HTTPS certificates and so forth, and it just felt like the tool set for that wasn't really ready. So we had a lot of bumps on the way. Maybe right now, if we would pick again, maybe it would be an option. I don't know. We use Docker a little bit on the build servers, but not for the production machinery. When will it go?
Open sourced. I don't think in the
I
near
don't
future.
think in the near future, but that's the thing. Like we haven't actually built massive amounts of source code by ourselves. We have just connected the cables around things that seem to do the work, because we haven't written Git, we haven't written all the AWS stack. We have just made the team city or the build server talk to those. put up, pull up changes from the Git, find out what to do, tell CloudFormation to do stuff with the CloudFormation templates and parameters. That pulls up the autoscaling groups and ALBs, and those are all public. Maybe we can give people more hints how we do it. Today we will show the demo. But,
we can actually start showing this, and how it's different from the Docker and Kubernetes. I guess we covered this.
Well, not in that much detail.
From Elastic Beanstalk. Why not Beanstalk?
Right now, the whole machinery that we have is under our own control. I see Thomas is trying to steal the screen.
Yep.
Okay. Maybe we just can press this one. Let's see if we have the mouse now. I hope so. It felt very similar when we started to do it at first, but we had issues with bootstrapping our applications in a nice way on the Beanstalk. Couldn't figure it out very well out of the box. I didn't think that was pretty much it. For the Kubernetes, we don't really know. We haven't given it a good test ride. One thing that we have used a lot to manage all the ACLs across the applications and the clusters of things is reusing the AWS tools, and I'm not sure how well the Kubernetes and stuff plays along with it. Thomas, can you throw the picture here, maybe? Just drag it over there and resize it to full screen. Over here, somewhere. Yes.
So we have, as you have seen, the application. You have submitted the question into.
Oh, this resolution is horrible. That's the one part that we didn't test before, how it works. You can recognize some of the
You don't test that.
But yeah, it's you can see over here, we have replaced database password as a secret. So that's the stuff that only the runtime machinery sees. When the build server is putting stuff together, it doesn't know the secrets. Otherwise, it would be very much like a superhero machine. I can access everything, right? I don't even need to hack your whatever development or your deployment targets. I will just take the deployment server. I will do everything from there. Shouldn't really. Shouldn't have access to those. And also, in general, it would be a nice design if you could actually open source whatever you have, and without the secrets, it would be unhackable for the people, for whatever kind of hackers on the internet. That would be a perfect design of the software. If it would be secure enough so that even if somebody steals your repo checkout, they will be like, I don't have the passwords, I don't have the keys, I have nothing.
That also answers the question where someone asked it by the version secrets. You mean in Git repository? That's not.
No,
we have separate storage for the.
Just make a search on the GitHub with a key like secret key or something. You will find a lot of stuff.
Yeah, but we have seen that. But
there's also the thing that in Git you can change things, and we don't actually think that you should change stuff. If you think right now, if I have a problem that, let's say my database password leaks, and I have to change it, and I don't have a maintenance window, so I can not take stuff down. How do I change the password for the stuff? I have servers running doing stuff. I expect that those servers, when I deploy them again, use the same password to connect to the database, the one that they had. So actually what I do is I define a new username, a new password for the database. Of course, fixing the roles for the access to access the data. And into the secrets, I will define a new secret, a new application config will say my database password is now the other name, whatever the secret's name is. And this way, whichever I deploy will get the configuration that it had to have. Otherwise, if you start to update secrets, your previous deployment is not repeatable anymore, it's gone.
But you need to deploy again.
You will deploy a new stack of machinery, yes. You can still fork out from the same, let's say, whatever Git version that you had, just fork out a new branch, deploy this one, just change the placeholder. And just so that we would actually have repeatable deploys. You don't really know how bad a repeatable deploy is unless you have some really, really big merchant that wants to tell you like, okay, there is here like 100,000 payments for a day. I want to process them, and just say like, I cannot. I don't know what my config was. It's not really a place that you can even be in. It's not acceptable. So here's that.
Yes. And this, as you can see, there is a color for the button you get in the application, and now the current color is white. So we just change this into green, and green button, and then commit and push. Changes.
So when we write code, nothing special is involved in the sense. People use whatever kind of editors they want.
But there was also one question, like how do you release breaking chains?
No. Is that the answer?
You have one, but you have one shared database.
Shared database for what? In the sense, all the microservices themselves have different databases. So, but yeah, let's say
new
if I have
all the version
if I have
the same database instance.
Yeah, that's the thing. Like all the database changes that you do have to be backwards compatible. Sometimes that means that you have to do several deploys to move from state A to state B. But that back to the window, like you don't have a real maintenance window. I cannot tell partners like Google, like I will not take any payments for the next 3 hours. I will change the database. They would be somewhat unhappy with this approach. Let's put it this way.
As we can see now, we are building the.
Yeah, the deployment itself happens in that sense in 2 phases. At first, we build the deployment package itself. We build very simple WAR files because they are small, light, and easy. In Docker, you would probably build like add-ons onto your Docker images and push them into a Docker registry. We just push WAR files into S3 because it's there, and S3 plays along very well with the machine's access rights.
How do you manage them? I mean, binary artifacts.
Come again?
So version, I mean, if you store WAR files in S3,
they're all
so
versioned.
yeah, I know, but if you have some microservice architecture, they have a dependency on versions sometimes.
So you mean across the cloud itself
Yeah.
to other stuff? In that sense, since the system is constantly evolving in one direction, you cannot actually say, okay, this one went bad, let's take this one back, and I also have to roll back this. That it would be somewhat unmanageable to calculate out all the stuff that you have to roll back. Since we do the deployment in like really gradual steps, it's not uncommon that when you have like when you're developing one feature, you do several like deployments during the day. It's just small incremental upgrades to see that you're going in the right direction. If you see that it's going in the wrong direction, you just take a step back and continue from there. And also, as said, if a machine is really bad, it doesn't even show up in the load balancers. It doesn't handle the traffic, so it doesn't destroy anything. At first, it just sits there and eats your money. It's still bad, but it's not so awful. So once the deployment package itself is ready, you can run the deploy task in the build server. Technically, we can change those 2 up and just run them on every git push, but as I said before, if you handle money, you don't want to let every push into the production, even if you think like, okay, I have tests, I have all sorts of like covers and things. Regarding the build server approach, I also recommend it to people just to serialize everybody around you. If you can deploy from your own machine, it's very easy to say, oh, don't run tests, I don't care. On the TeamCity server or any kind of build server, it's really hard to hide to disable the tests for the deploy. And somebody should kick you really hard also. For us on some applications, it's even the check style checks at first that have to pass. So we know the code is readable, the tests have been run, everything is fine, and you can actually deploy it. There is no, I know this will work, hit the enter and just blow up things. Don't, awful idea. So yeah, in that sense, So this is our monitoring dashboard.
This is current traffic.
The current traffic received by the machine, it shows the requests that it's handling. And can you open up the first graph from here? Just the arrow to the left. So it actually shows the machine that's handling it. So when the new machine comes up, it will start to log events as well. Okay. And we see automatically from here, like even that's not really automatic, our eyes are involved, but we can see that okay, it started to handle something. This way we can also identify like with a real service, you can imagine that we have the timed matrix. Does it perform well in terms of performance? Does it get enough traffic? Does it have the same success rate? Because when you know anything about Kibana, then you can actually click on those names and you can filter the traffic just for this one or just for a set of them. It's really handy. Pretty sure like whatever kind of like graphic tools that you use for monitoring stuff, they have the similar capabilities. If they don't have, pick something else. For us, Kibana works really well. And yeah, we can see that node is starting to get traffic equal with the other one.
So some should find the button is green, not white now.
Yes, there's a blue button on
green now.
On the bottom.
What a wonderful tool you built.
Yeah, it's a lot of work to get the button green, but it's just to show that it's actually working.
And one thing you also can...
only one machine right now?
Yes, this we just deployed one machine, but from here we can see this is the ALP and
is
how
there any way you can increase your resolution with Control Plus in the browser?
No, that's
not. Yeah, that's right. Just drag it down a little bit. So, as we mentioned before, that there are load balancers and target groups. When we deploy the machines, we actually tell the machines that this target group is where you belong, and the load balancers are actively start to poll. Okay, that's my target group. I poll all the guys in there. I will see if they're healthy. If you have nodes that actually don't have HTTP traffic, they still have a dummy load balancer that's polling them. It doesn't accept any requests, but it's just there to measure all the health, make sure everybody's working, everybody's healthy. The instances themselves can be seen down here. Something that we didn't do during our deployment is to increase the amount of machines.
Yeah, but this also can be done now.
Yes, well, maybe not through the deployment cycle, but just through it from the AWS console. Like, let's say you don't want to make use of whatever kind of special tool set, but you're interested in the auto-scaling groups. On the left-hand side, a bit down, is the auto-scaling groups controls over there. And in here, why don't I see anything?
1 to 4.
Did you click something funny?
No, it's just...
okay, it just took a while to load. You can actually see that there are different auto-scaling groups for the different versions of the app. There's an edit button there on the right-hand side. Yes. And when you scroll down here, you can actually say how many machines you want. So you can say that, okay, let's have at least 2 machines. So you can set the desired and minimum both 2. And when you apply it, there's no, like, really nothing else that you have to do. I think the save button is in a very illogical position, but fine. That's not our fault. In general, we think that AWS has actually done a good job there. It has even protected your wallet a little bit in the sense that it has reasonable timers that say, okay, I launched a set of machines in the last 5 minutes, I will not launch more. I don't know how well you can control this with Kubernetes or stuff like this. And can Kubernetes actually launch new machines, also aside from Docker instances inside of machines?
At least on Google, yeah.
Okay, right. That's good. Because yeah, that's the thing. Like, you don't like. For us, the worst scenario that we have to fix is like on a Saturday morning against Sunday, when you get either like a malfunction in a server, or you get load that you didn't expect, you need new fresh machines to handle the situation, either just to be healthy or to have just more machines to run things. And if then you have to wake up, you have to provision yourself new machines, run Ansible, Chef, whatever kind of things to bring them up even, by the time you get there, a lot of time has passed. It may feel fast for you, but actually if you start to measure the time, there is a lot of work involved. And also for developers, they don't feel that they have any control over anything that's going on, unless you give everybody chef rights and super user powers, and then you go like, why even bother having passwords then? Maybe I just give you the database shell and you will update the payment status yourself, so we don't have to go through the Google hassle. So yeah, Kibana is doing a very good job at assigning colors, but now we actually have a new machine running there. And it's handling traffic. So, and now if you look at the same submit button changing color, if you refresh, you should actually get it in another like cycle in the sense. Before, if you try to switch between white and green, now it's white, green, green. In the same way, if you do a gradual rollout of a new feature that's really scary, you can say, okay, the old cluster had 10 machines, the new one will have 1. And you can have a bit less than 10% traffic on the new machine, just to be like damaging less the stuff that you're maybe possibly breaking. That's very greenish.
So when you are deploying new changes, you have two sets of machines with old and new versions, and user
at the same time
will be distributed between these two versions evenly, like half on the old version.
Well, it's the load balancer is treating everybody equally. So if there is equal amount of machines in the new and old groups, it's 50-50. If the new cluster has 2 machines, like right now, and the old one had 1, then it's actually 33 and 66.
So you cannot control this distribution to change it gradually, or like in A/B test, like 20% on you and.
No, over this we have no control. I don't know if we will ever want it. It seems like a good idea, but in practice, we will probably use it very rarely. We have had similar like feature switches, but for us, the way that we have internally set up the application is that we have front-end machines that are available from the internet, and then like a cluster of internal machines that only talk to message queues. And in there, it doesn't make much sense to twiddle around the load balancer percentages. We rather work on the rabbit queues and message keys, and we can say, okay, those messages only go to those instances, everything else goes over here. And over there we have more gradual control, because with RabbitMQ you can go really nuts if you want to think about how you can route traffic. That's a completely other topic. But on the front end side, if you look around on the portable web pages, you don't really see so many web pages that we have, especially from the service side. Internally, the amount of servers, I don't even remember anymore. So the production is around 300 machines running around, so there's a bunch of things to manage. And yeah, this is right now our mighty deployment tool. Maybe we will get it out from the build server at some point. The main thing is just that we are leveraging a lot of on the AWS stuff, and in the next talk, hopefully it will be properly trashed.
Okay, then we are heavily
over time as well.
Wrapping up. Martin and Mustafa will stick around to answer any more questions you might have. We'll take a small break. We'll be back here 8:30 to listen to Alar talk about how this is all bad, what we're doing.
Yes.
Okay, thank you everybody. Thank you, Martin.
Mustafa, whenever you say the color, that was off because the screen tool that's referring to inverting the bars.
Let's start gathering around.
pane see töötab või? jah, eks see on fine.
mis te mulle siia panite? Siia kas slaidid panite või te saate?
Sul on siin notes'id.
Kui te saate mulle siia slaidid? Ei saa vist.
Sul on väikselt on näha slaide.
Kätte meile lugeda. Mis ma ütlen peale ka?
Saad hakkama? Miks ei saa? Sa oled võimekas mees. Kõik või? Lähed ära?
Äkki saate või sinna peale?
No slaidid on kõigepealt väiksed
Sa näed väiksele vaikselt
me keerame nüüd sinu poole natukene.
Okei.
Hästi
Mul on
natuke.
lihtsalt vaja mingeid pointereid.
Nii, try again. Good. So, I hope you enjoyed the first talk. I hope you enjoyed this wonderful evening so far. Next up is Mr. Alar Raul from Concise Systems. He is the infra team lead there, and he'll be talking about AWS, opting into it, making the decision to actually host your services there, and what does it mean for you long term and short term, all terms. So, without further ado, Mr. Raul.
So, hello. Maybe a bit about Concise. Just a quick one. Concise just wants to help you if you need. We just want to lift off the burden of IT from you. So if you ever need anything, just contact us. And for today's talk, we are talking about one of our stories where we moved from conventional data center solution to cloud-based solution, and we chose AWS. And the little background, the client had at the time 1.6 million active clients. And what we were happy about was that we were developing the software, and we had implemented the automated deployment workflows. It also used Nexus, like it was told there before, today also. And it was used for everything, so including the core services, databases, message queues, and so on. And what we were not happy was the managed data center service. We struggled with every kind of problems, performance issues, configuration change issues. The time was always critical, the changes were quite slow, and so on, so on. And also the backups and the managed Linux servers were problematic because they didn't patch those and so on. And why we looked to move the services to the cloud? Because of the overhead of the physical infrastructure, like I said, overhead of networking and security, because the conventional security and networking is quite cumbersome, and cloud is quite good to solve that one. And also one thing was also the cost optimization part. And what we wanted to achieve was easy to manage and pipeline infrastructure from A to C, starting from networking and ending up with service endpoints. Also the better resource utilization, and of course automate everything. And how do you can today I'm talking about the concerns and issues we faced, not the solutions we used. Like the last talk said, we are only here to connect the cables, not to invent something new. So, but here are some good examples how you can pay too much for your infra. For example, you can overload your cloud with instances to deploy every service to its own instance, to use high availability where you maybe shouldn't. Also the network traffic between zones. If you are small, you are not noticing it, but if you are growing, you will notice it. Today we also struggling with it still, because we are paying quite a lot of money for the in-between zones network traffic. Session replication, backups and so on. And also the capacity or performance of different components is the issue, because you may think that you have a really good setup with a really good instances and really good block device setup, but at one point you just see that okay, something is not good, and it turns out that maybe the instance is throttling your block device IOs. And you need to keep an eye on it. We faced those problems in the test environments. And also the data lifecycle management and backups are really crucial, because you can save a lot of disk space or storage space, and otherwise if you are making backups from the old data, let's say daily, then you also waste quite a lot of money for the traffic and for the block devices or S3 buckets or whatever. And also the replication to third parties is quite hard, maybe. And how Amazon tricks you to pay your monies. Limits on every level. You need to know those. You better should read through all the details, because they can bite you really hard, like I said before. T2 instances. I know that Fortamo is quite keen to use those, but we are not, because they are not really reliable. But it depends how you design your system. If you can lose your instances, or the instance can go off from your network, then it's okay. But yeah, they can give you quite a bit of troubles. And also the burst and balances, it goes to the limits. And one really nice thing is the disk or block device block sizes. Who knows how big is Amazon I/O? One block I/O.
1 megabyte?
No. 256 kilobytes. And how big is the conventional file system block size?
4 kilobytes?
8. And a little, yeah, okay. But a little calculation says that the bigger block size you use, the more you win, and so on. So you can opt out or opt up your IO bandwidth quite a lot if using right tools. And CloudWatch, okay, it's nice, but not really usable because it's slow. It can help you time to time, but don't really rely on it. And if you want to export the metrics to somewhere else, it also costs you money. We are using M4, R4 instances for databases, and C4, R4, and T2 for applications. T2s are used for the applications which we don't really care of dying. And the old good question, maybe I can build the core services or the core components by myself instead of using Amazon provided services like RDS databases, some memcaches or something like that. Then again, you need to think a bit how to split your databases. Going with microservices is a really good idea. Like in here, I also really like the idea and we are actively using it, but still we're having some quite big databases and big services. Okay, the good one, not everything needs a transactional database. You shouldn't store your binary blobs inside the database. It's pointless. Maybe you should use S3 buckets. And now my favorite part, using CFS for data storage. It can help you in plenty of situations, actually in AWS. It can boost your performance, IO performance, because the CFS has a 128 kilobyte block size, up to it. It has compression, really low overhead. With that one, we are running our all the databases on CFS with compression enabled, and the overhead of compression is just minimal. It doesn't affect it. And also it caches IOs quite smartly. You should check it. And also what is the most beneficial for us from using CFS is the backup solution which we build up inside our house. So basically we are using CFS snapshots. Everyone knows what snapshots are, how they are working. We are making snapshots in over every 1 minute, and we are replicating them over the network. Over the network we are replicating the incremental data sets, and doing it over 10 minutes. So we have basically full backup of all our databases over every 10 minutes in the remote site, but with quite minimal impact for the production databases and for the networking, because we are using incrementals. And also it gives us a really nice feature, which is recovery or recovery testing, or let's say someone is coming to your room and saying, okay, I lose some data 2 days ago, I want it back. From that solution, starting up a database from that time will take in our system around 2 to 3 minutes. And also we are running our business intelligence databases or reporting databases on the clones. So again, we are lifting off the reporting or analyzing load from the production databases. This is quite nice. I can talk about this solution later. I have a picture also. And the last one is, okay, you can optimize your redeployments. As I said before, we like to use the infrastructure as the pipeline from A to C, and if we are using, for example, RDS databases, we just cannot upgrade the databases seamlessly. We need to do something more, and sometimes we cannot, for example, predict the downtime. And also, if using RDS databases, you cannot use CFS, and so on. And here is the basic schema of the CFS backup solution. It's actually a database which is master and slave. The slave part there in the right or in the middle is has quite low limits, because it only needs to take care of replication of and the consistency of the data. And then again, we are making CFS snapshots. We are replicating those to remote or central backup servers and to remote servers. And for the reporting, we are starting up the reporting databases whenever it's needed. And it's also seamless for the production because it's in the different server and in the different block devices. If anyone is interested, I can share the details later. And this is the, let's say, the one you maybe won't hit in the beginning, but definitely you will have a problem when you have some third-party integration who just says that, okay guys, I can do only IP-based whitelisting, and then you are in trouble. You need to make some static proxies or whatever. Also the third-party VPNs like to whitelist your IPs and so on. And until recently, there was no way to easily pair together different Amazon regions. It was launched last month in EU, so now you can. Old stuff about using AWS. The biggest joke has been until now the support. If you need to raise some limits, then take your time, because most of the times the guys from India working in the support doesn't understand what we want. We had a case where they decreased our limits. They asked over several times, and then they increased randomly some other stuff and so on. So it took, I don't know, 3 days. So if you have an issue and you need to deploy more instances, then you can be in the problem. So prepare. And really nice things, what we are liking the most in AWS, of course the DNS management and the automatic certificate management. We can say that that old good one, that your service will be down because of outdated certificate, days are over. And the last one is security groups. They are really awesome. You should use those. They are really nice. And the conclusion of that project. The project altogether took less than 1 year. Actually, the first services were moved over in first few months, but there were several issues we were facing. For example, multicast, we used multicast. Also the third-party integrations and so on. And the really nice one, again, that migrating over the core service meant only 11-minute downtime for us, for the whole system. And the cost issue, I raised before, went down by 10%, but the good thing is that now we have a really customizable system, really well monitorable system, manageable, and so on. It's not a bad result, could be worse. And our client rated us about 10 out of 10. They are still happy, and now they are running 1.5 million active users in the same setup, by the way.
I have a question
Yeah.
about the cost. Did the cost go down just for the machinery or combined with the manpower that you actually need to manage?
It was only the machinery.
Okay. But the manpower?
Infrastructure. Manpower cost, we cannot calculate it directly because we added some or introduce some new functions. So at the end of the day, I think the manpower cost will also go down, because at the moment we are not doing anything by hand in the systems. Everything is automated. We are planning that we are taking off SSH access to the instances at all, so everything should be handled somewhere else, not inside the instances. Did it answer?
Yes.
Mm-hmm. And thank you. So, questions? Mm-hmm.
Have you considered any other cloud providers like Microsoft Azure, like Entity?
Yeah, we considered, but at the time we made the decision, AWS API was the best one to implement everything.
Based on what criteria? Brightness or?
Based on capability to automate everything. As we are using Ansible, then there were the best coverage of the built-in AWS modules.
Okay.
Talking directly with AWS.
It
It was one with area, and another one is that it was the biggest one. There were several other issues also. The regions, the cost, the support levels, and so on. We are not using the basic support, and the cost of support is quite high.
How do you orchestrate the creation of new resources and cleaning up afterwards when you don't need them, so you don't forget like security groups hanging around and stuff like this?
It's basically those are Git repositories, and if something phases out, we just make a commit and play through the pipelines. Goes for the instances, for AMIs and so on. And we are using pre-built and customized AMIs, also built by our Ansible scripts. This is actually the part we are running separately from the deployments, because it's not needed to be the part of deployment. Anything else?
You moved to AWS from where?
From the conventional data center located in Sweden, in Stockholm. So they were using, I think, VMware clusters, but it didn't make any difference for us because it was quite invisible for us. So
and
we didn't get.
Before you were managing like servers, like just hardware, you were creating your own virtual machines, or on which level it was before?
It was provided, and because of that, it was quite hard. We even didn't have VMware level monitoring access for the system, so quite tricky to run enterprise businesses on that level.
You mentioned the restoration times, but we didn't really talk about the sizes of the databases.
The time we moved over, our total size of databases, there were two main databases. One was around 300 gigabytes, and another one was 250 Gs. So not a lot, but also not so little ones.
Do we have any more questions from the crowd?
Maybe you, Martin, have something?
No, I know everything.
And Martin, I didn't say anything bad about your solution.
Yes, you only told the truth, which is what we're after.
Well, actually, some of the stuff was overlapping in the sense that for the databases we also use R4s and C4s and machines of those kinds.
Mhm.
So if you have anything IO intensive, T2s are not the machines you're looking for. Don't
Yeah,
even
Applications fine, but
If you need IOs or network IOs which are dedicated or guaranteed, then you can't use T2s, and that's it.
very cool.
You need to pay the money.
So anyway, if there are no more questions, then thank you all. Thank you everybody for coming. Sure. So as promised, the doors will be open around 10:30, 11ish. So stick around, let's chat. By the way, I didn't introduce myself, did I? So yeah, I also work here at Fortuma. I'm the VP of engineering. So if you have any questions about Fortuma or anything, feel free to come and ask me stuff. So anyway, thank you everybody. Have a great evening.
Thank you too.
I would still opt in jobs because I've seen Azure.
Oh really? Where?
It's not bad.